All right, I'm going to try to walk you through how we do this in our calculus class. Hopefully it relates to what you're doing. Pun intended, related rates. I have some steps here on the left that we're going to try to follow. But before we do that, let's just read this problem together. A bowl with a circular top, base, and cross-section bounded by y equals x squared for x is bigger than or equal to 0, and by y equals negative x cubed, I said squared, this is cubed, for x is less than 0 is empty at time t equals 0 seconds. If water is being added to the bowl so that the height of the water is rising at a half a centimeter per second, what rate is the radius of the circle determined by the surface of the water, changing when the height of the water is 27/8 of a centimeter? So here's my suggestion. First step, identify any variables that are in this problem. So let's look at these. It mentions that this is a circular top. That's referring to this part right here. If that's circular, then that must have a radius. So the radius of this is going to go from the center of the circle to the circle. This is in a coordinate plane, but what we're saying here is that x is equal to the radius. And it's being measured in centimeters. So this is what I mean when I say define the variables. It says it's bounded by the curve y equals x cubed. Well, to know at any specific height of this, y represents the height. That's also measured in centimeters. So there's two variables that we've defined. It mentions, so using this equation, and we could just as easily have used this equation because that represents this part over here. I'm just going to use the positive version. It mentions both, it's just saying this is symmetric to the y-axis. It's empty when the time is t equals 3 seconds, so that must mean that t is measuring time, and the units is seconds. Let's see, any more variables in this? I don't think so. If it mentioned volume or area, those would be new variables. It does not mention those. So step 1, identify all the variables involved in the problem. So I'm just going to put a little number 1 beside this. That part's done. Usually that part's pretty simple. Part 2, translate the phrases in the sentences to calculus. That is not as simple. Let's go back and relook at this problem and see if we can do that. Calculus is about rates of change. If water, I'm down here, if water is being added to the bowl so that the height of the water is rising at a half a centimeter per second, that is a rate. So in calculus, what we would do, this is step 2, we would say that the change in height, we said that y was the height, with respect to time, the reason it's time, this is measured in centimeters per second. So the top is in centimeters, the bottom's in seconds. It says that is equal to 1/2 a centimeter per second. Now notice the consistency here. We're saying y is being measured in centimeters. We are saying that t is being measured in seconds. Very consistent. Continuing, here's the question. I like to put a box around the question. What rate is the radius of the circle? And then it says, comma, 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 changing when the height is 27/8 of a centimeter. Here's what we're supposed to find. Always write out the question in calculus. Find the change of the radius, and I used an r, but I said radius was x. Find the change in x with respect to time when it says the height, which we're saying is y, is 27/8. Once you get to this point, you likely have done the hardest parts. which is translating the sentences in this problem into calculus. So that completes step 2. Step 3, identify if there are any variables in the problem that remain constant, things that don't change. None of those happen in this problem. Everything's changing. Number 4, write an equation from your brain. This is something that you often have to do. We'll get into more of that later, but for this problem, we don't need that because they give us an equation. They give us a specific equation, and that equation that they give us is that y equals x cubed. Yada, yada, yada. Step 5. Implicitly differentiate both sides of the equation with respect to time. Now, I'm assuming you know how to do implicit differentiation. If you don't, send me a message and I will explain that. But essentially, we're going to take the derivative of both sides of the equation with respect to time. Derivative of y and the derivative of x cubed. If you take the derivative of y, its derivative is just 1. But we're taking the derivative with respect to the improper variable because this is with respect to t, but this is supposed to be with respect, or we're supposed to be the derivative of a variable of y. So we're going to say that it's just dy over dt. Times 1 technically, but we don't need to write the 1. On the right side of the equation, derivative of x cubed is 3x squared, but it was the wrong variable. So we were going to say dx over dt. That's implicit differentiation. Now, this should be simple from here. It isn't, but it should be simple. We are trying to figure out what this is. That's what it says to find. Do we know what dy over dt is? We sure do. It's a half. Do we know what x is? We do not. We are not told any place what the value of x is. What we do have, we have something that's related to the x. That's why this stuff's called related rates. We know what y is. We know that y is 27/8. And you're probably thinking, how does that help me? There's no y in this problem. But y and x have a special relationship. Whatever y is, x is the cubed root of that number. So if we take this equation again, so this here is the general case. So this is true at any time. This here is going to be at a specific case. The specific case is the y value for this. I wrote that wrong. The y value is 27/8. And once again, the reason we have to know what x is because our main equation here has an x in it. If we cube root both sides, we're going to get 9, scratch that, we're going to get 3 halves is x. What that tells us is, if we go back up to here when we did step 2, we now know that when y is 27/8, x is also 3 halves. Now, we could have found that at the very beginning, but I didn't know we needed to know what x was at the beginning. I didn't know it until we got to this step in the problem. So now to continue, we're trying to get dx over dt by itself. I am going to plug in the things that I know. So we're going to figure this out when x is equal to 3 halves, and we were told at the beginning that the change in the height with respect to time is 1/2 centimeter. So those things get plugged in. I'm just writing that down and boxing it in just to emphasize what's happening. I don't think it's important that you write this part down. Unless you're having some trouble, then you would definitely want to write it down. Now it is a simple algebra problem. We're trying to get dx over dt by itself. This would be step 4, I wrote the equation. Step 5, I found the derivative implicitly. Step 6, I am substituting all the instantaneous rates and values for the variables in solving for the remaining variable. If you square a fraction, you square the top and you square the bottom. This is going to be 1/2 equals 27/4 dx over dt. Then to get dx over dt by itself, multiply both sides by 4/27. And cancel 2 from the top and bottom, and you get 2 over 27 equals dx over dt. You must put with this the units. And it's easy to figure out the units. What did we say x was being measured in? Well, if you look up at your notes, it says centimeters. What did we say t was being measured in? We said that was seconds. So to answer this question in like a sentence form, which you're probably not asked to do that, and I make my students do it. If you look back at the question, in sentence form, we could say something like, when the height of the water is 1/2 centimeter. No, that's not true. When the height of the water is 27/8 of a centimeter, the radius of the circle is increasing by 2/27 of a centimeter every second. So that concludes that problem. Any specific parts of this that you're having trouble with, you didn't understand, you need me to explain again, let me know. I'd be happy to do that.